Today's video can be found in your 5C packet on page 11. The top part of it is like a problem of the day, this algebra review. So do those top four on your own and we'll go over those in class. We're going back to word problems. And there's many ways that you can set up a word problem before you start writing the equation. You've got to read the problem carefully. And you know me, I like to, take it apart, write on top of it, find the equal sign, and then set up the let statements or a diagram or a bar model or a table. You can see here the four ways that you could set up the word problem with the idea of, okay, what is it that I have to find before I write the equation? And you can use any one of these four models throughout the next several pages in the packet as we're working on word problems. First word problem here, it says, the length of one side of a parallelogram is 3 more than twice the adjacent side. The perimeter of the parallelogram is 26. Find the length of each side. This is a geometry, shape question. So my gut is to go to the diagram first. So I'm going to do that model first, but I am going to fill in this word problem showing you all 4 different ways to set it up. So it is a parallelogram. So I'm going to draw a parallelogram like it says here, diagram. And it says that the length of one side of a parallelogram is 3 more than twice the width. So I know that that's my x, the adjacent side, twice the adjacent side. The length is, so it's telling me something about the length. That's not my unknown. The width is my unknown, or the adjacent side. I'm going to call it width. The length is 3 more than twice the adjacent side. So 3 more than 2x. That's the length. So I'm going to now apply that to my picture. 3 more than 2x or 2x plus 3, it doesn't really matter. And I'm going to write it on both of my lengths. And so my width is x. So that's how I would set up that word problem, and then with a diagram. And then I would write the equation. We'll get to that in a moment. How would I bar model this example? Well, the length is 3 more than twice the width. So the width, or the adjacent side, is the model, or the bar. So one bar represents that x. That's the width. And the length is 2x. So I'm going to draw 2 of these. Plus 3. That's the length. So I'm going to put a little plus 3 over here. An x plus 3. So that's the length. So this is how I would do it in a bar model. The table way, okay, so again, I'm going to make a table. The width is my x, and the length is twice that, 3 more than twice that width. So 2x plus 3. So I would set it up in like a table format here. The let statements. Okay, well, that's generally the method that I always go to. Now, I'm an algebra person. I'm going to write let statements. I almost always use let statements. If it's a geometry one, though, I do use the picture. So let x equal the width, or that what's called the adjacent side. I'm calling it the width. And let twice that plus 3 more, right? The length is 3 more than twice the width. Okay, 4 different ways that I could set up this problem. Now I've got to write the equation that goes with this. The equation is the perimeter of the parallelogram is, that's the equal sign, 126. Find the length of each side. The perimeter of the parallelogram is 126. Perimeter. So the perimeter, gotta have a formula. It's 2 times the length plus 2 times the width, just like a rectangle, right? They told me that it's 126. 2 lengths, the lengths is 2x plus 3. I'm looking at my picture right here. Plus my widths is 2x's. So I'm going to distribute And I get 4x plus 6. 2 times 3 is 6, plus 2 more x's. Is that 126? I could have just gone to my picture and said, okay, 2x plus 2x is 4x, plus 1 more x, plus 1 more x gives me, yep, 6x, because that's my like terms here. Plus 3 is 6. And I could have started, after writing the formula, I could have gone right to this. 126 is 6x plus 6. Solving this equation, because I need to know the length of each side, I get 120 equals 6x, because I subtracted 6 from both sides. Dividing by 6, I get 20 is x. Ooh, not done. I have 2 things that I have to find. So 20 equals x is not the last thing that I'm going to do. I'm going to do 2 times that 20 plus 3 to get 43 is my length. 20 is my width, and 43 is my length. So if I add, here's my little check, 43 plus 43 plus 20 plus 20, the perimeter of that parallelogram, it's 6, 4, 8, 10, 12, 126, yippee, it checks, got the right answer. Now, as you know, sabling, sentence answer box label, I call it sable. We're going to answer in a full sentence. So the length is 43. Length of one side. Oh, it doesn't say a unit on here. Oh, 43 units. Doesn't say inches, feet, yards, or mile, that the total perimeter is 126 of something. So it's units. The length is 43 units, and the width of that parallelogram is 20 units. Oh, I'm going to write off the board. Sentence answer box label. Let's go on to the next page. Write an equation to represent each situation, then solve it. Joy's bank account was $103.48. After 2 checks are cashed, each for the same amount, her balance is negative $31.36. Oh, Joy, can't have a negative. Bank's not going to be happy with you. What is the amount A, oh, they're telling me what letter to use, in dollars for each check? 2 of them are exactly the same. So I'm going to say, they're telling me what to use. Let A equal the amount of the check, right? And I'm using the let statement. I'm not using the table or the diagram method or the bar. I could use bar modeling. So she starts with $103. Now I'm writing my equation, which that line's not long enough, so I'm putting it down here. $103.48. After she cashes 2 of the exact same check, so 2 A's, she has a negative balance. Ooh, not good. Okay, so here's our equation. After subtracting 103.48 from both sides, you get negative 2A equals negative 134.84. Adding those together, same signs, adding, keep. Dividing by negative 2, you get A equals 67.42. So negative 134.84 plus that positive 103, right? Negative 134, so I'm checking here, 84, plus what I started in the balance, or Joy started, 103.48. Okay, different sign, subtract. Will I get, yep, 36, and for 1, 13, 31.36, negative 31.36. So yes, it checks. So the amount of each check, here's my sable, the amount of each check, because they were the same, is, and dollar sign here, 67, don't forget our labels, 42. Sentence answer box label. Next question. Ms. McCrory buys 12 student tickets and 12 adult tickets to a play. The total amount she pays for the tickets is $359.40. If the price of each student ticket is $10.25, what is A, the price of each adult ticket? Okay, so they're telling us again what the letter is. So I'm going to write a let statement. Let A equal the adult ticket price. Adult money, price for the ticket, right? And what information do I have? Each student ticket is $10.25, and she buys 12 of these. So 12 times that $10.25 plus 12 adults, 12 A's, gives us a total of $359.40. Remember, we don't put dollar signs in our work. So we've got to multiply that. And when you multiply that out, you get $123 even plus 12A equals $359.40. So we subtract 123 from both sides. And we get 12 adult tickets. Must have a value of $236.40. Yes, I can annex those zeros and subtract. So cancel. And when I divide by 12 on both sides, I get that the adult ticket for one must have been $19.70. So 12 times $19.70 is $236.40. Did it on a calculator. And 12 times $10.25 is $123. And when you add those together, you do get $359.40. So I check this on a calculator, always check. And then sabling this, each adult ticket costs, costs $19.70. Or the cost of each adult ticket was $19.70. And that's it for today's video.